All right, one thing that LTspice can do that maybe you've discovered and maybe you haven't is that you can actually draw two schematics at the same time and run a simulation on both of them and basically use this as a way to compare the behavior of one circuit to another. So what I've got here is a 10x inverting amplifier. It uses a 741 op amp, and the Spice file for that is already imported as a Spice directive. Because this is being used with the open scopes, I've got a plus and minus 4 volt supply voltage applied to the op amp, and I'm driving it with a sinusoid, at least for now. But we'll see how we can change that. All right, so if we want to do two circuits at the same time, the first thing I'm going to do is use the copy tool. So there is the duplicate tool, where you can highlight something and it makes a duplicate copy. And in one thing to note that does is it actually relabels all the resistors and capacitors, so they get kind of a new part number. But all the nodes are left labeled in the same way, so we're still applying the same plus and minus 4 volts. It's got the same input source for both circuits, so we can compare, the output for, the same input of the two different circuits. All right, so the feature that I'm going to add is a capacitor. Like, suppose I saw a circuit where, someone put a capacitor in parallel with the feedback resistor, and we wanted to know, how does this change the circuit behavior? All right, well, let's just build the circuit and see. And I'll pick a capacitance value for that of 10 nanofarads. And yeah, initially this is set to run a transient simulation, so we can go ahead and leave that. It's going to run a transient simulation for 1/10 of a second. At 100 hertz, that should give us 10 oscillations. Okay, so now we can zoom in on the schematic, and we can measure V in on either circuit, and it's going to be a plus or minus 100 millivolt signal. And now we can measure V out on the two signals, so on the two circuits. So for the lower circuit, which was the original times 10 inverting, it looks like that. And then for the one with the capacitor in parallel, it looks like that. So it's overlaid. And so we see basically no difference in this case. If we were to change the simulation command, so let me zoom in on the simulation command and edit that. So I'm going to switch this from a transient analysis to an AC analysis. We're going to do a decade sweep. We're going to go like 10 points per decade, a start frequency of like 10 hertz, stop frequency of, let's say, 100 kilohertz. And in order to do that, we have to adjust the source to have a different format. So we have to set it to type none and an AC amplitude of 1, and that is what we need to do for the Bode plot. So let's hit run again. And now we're actually able to see the difference between the two outputs. So if we just focus on one at a time, the blue is able to maintain its roughly 20 dB gain, or a factor of 10 gain, out to about, I guess we hit the 3D point at around 100 kilohertz, it looks like. On the other hand, for the second circuit, it actually hits a 3 dB point much sooner. So this acts kind of like a low pass filter, and so we hit 17 dB, a little above a kilohertz. And so the nice feature of this that I just wanted to demonstrate is that it lets you show two circuits simultaneously. On your diagram, you can run the simulation on both at the same time, and then when you take your measurements, you can actually use that to compare the outputs of the two circuits. Just a handy feature that you may or may not have realized LTspice could do.